Hello and welcome to Mathematics Made Easier channel. This is your favorite mathematics tutor, Comfort Amuakun Atam. Today, I'm going to take you through some proofs of formulas and the mensuration. So relax, pick your jolters, and go through today's class with me. So the first proof we are going to look at is, let's consider these two circles. The first circle, and we are making reference to our previous lesson on the parts of a circle. What did we say a line dividing a circle into two equal parts is? We said that a line dividing a circle into equal parts is the diameter of the circle. So we take this as D1. And the distance around the circle, we label it as our circumference. We are taking that also as C1. Then we pick another circle. So we are going to have D2 and C2. Now let's compare these two circles. From these two circles, which of them do you think will have a larger diameter? Excellent. That is the second circle. Why? Good. Because it is bigger than the first one. So we can conclude that the bigger the circle, the larger its diameter. And so with this, we can say that C is directly proportional to D, where C is the circumference of a circle and D is our diameter. So introducing our constant K, we are going to have C is equal to KD. I know that in mathematics, the only constant is pi. So we have K to be pi. So substituting this into this equation, we are going to have C is equal to pi D. This is a formula to use when you are treating or when we are dealing with the circumference of a circle, when diameter is given. Now let's look at something. We also said that 2 radii is equal to 1 diameter. Good. So we are going to have 2r is equal to 1d. And we are going to substitute this into this equation as well. We are going to have C is equal to, wherever we see D, we put 2r over there. So this is giving us pi bracket 2r. So let's rearrange this to give us C is equal to 2 pi r. This is also the formula to use when you are finding for the circumference of a circle when radius is involved. Excellent. Let's move on. Now let's consider these two circles again. So the first circle, and we said that a line from the center of a circle to any part of the circle is called the radius. So this is R1. I'll pick another circle and label my radius as R2. Now, considering these two circles, which of them do you think will have or will occupy a larger area? That is circle 2, the second circle, right? Why? Because it is bigger than the first one. So if you have two balls of different sizes, which of them do you think will occupy a larger area? The bigger one. So with this, we can also say that area is directly proportional to r squared. We proved this in one of our lessons. Go there and refer. So A is directly proportional to r squared. Introducing our constant K, we are going to have A is equal to KR squared. Good. Then you know that pi is constant. So we are substituting this formula into this equation to give us A is equal to pi r squared. This is a formula to use when we are finding for the area of a circle, where r is our radius and A is the area. I believe you are enjoying the class and you are learning a lot. Let's move to the next proof. Let's consider the circle as well. And we said that two radii and an arc forms excellent a sector. So there's a sector with my angle theta over here. So with this, we can say that C is equal to 360 degrees. That's the circumference. Also equal to 2 pi r. We just proved it. And picking this angle theta over here, what are we going to have over here? If the whole circle 360 degrees is giving me 2 pi r, part of it will give us a smaller amount. So if less, more will divide. We are going to have 360. We are going to have theta, that's the angle here, theta over 360 degrees times 2 pi r. 2 pi r. So this gives us, let's pick this as A, B. And this will give us the length of the arc. So length of arc AB is equal to theta over 360 degrees times 2 pi r. Good. Now, in our next lesson, I'm going to prove the area of a sector that is minor 1 and a major sector. With this, I will leave you with this question. So try this, and it is examinable. I have the circle. Now my sector being drawn. The angle is 60 degrees. And now my radius to be 12 centimeters. The arc is of AB. Good. So from the diagram, find I, the length of the minor arc AB. The length of the minor arc AB. I, the area of the minor arc. So the area of the minor sector. O, so this is center O, A, B. So I'll leave you with this question, and I believe this tutorial was helpful. Thank you so much for your time. I will encourage you to solve more questions on your own as well. Please do not forget to like, share, and click on the subscription button to subscribe to this channel for more. So we meet again. Please stay safe and learn hard. Bye.